In this video we will use IPSE GO and the Advanced Power Plant Library IPSElib to set up a very simple process model that contains nothing but a single stream. I will use this simple example to show you how you can define and use compositions. You will see how IPSE GO reacts to missing or wrong input. To create the new project, click in the dashboard on New Project. Select IPSElib, and enter a project name. Although not mandatory, it is always a good idea to enter a short description as well. Then proceed to create the project. IPSE GO now displays the new project as tile with the project name. Click on the tile to open the project in the flowsheet editor. Here we can set up the process model graphically. On the left side of the editor is the icon bar. There you find icons representing all unit models available in IPSElib. To set up the process model, we select from the icon bar a source and then click in the workspace where we want to place it. We then add a sink in the same way. We can rotate the icons by pressing Ctrl+R or by clicking on the rotate command in the menu bar. The icons in IPSE GO show terminals where you can attach connections. The terminal color reflects the type of the connection. In IPSElib, green terminals are for streams. Connections in IPSE GO always have an orientation. This is reflected by the appearance of the terminal. Terminals for outgoing connections are shown as open boxes while terminals for incoming connections are filled boxes. To start drawing the connection, click on the terminal at the source. Click for any intermediate point somewhere in the workspace, and click on the terminal of the sink to finish creating the connection. IPSE GO automatically creates the correct type of connection, a stream. Obviously the model is not yet complete, so that we have to expect some error messages. Let us run a calculation to see how the system reports missing information and errors. To start the calculation, press the play button. IPSE GO tells us that in stream 001, the composition is missing. If we click on the error message, the data input dialog for stream 001 is opened, so that we can define a composition. In IPSElib, compositions are represented by global objects. Streams refer to these objects. In this way, all streams that use the same working fluid can refer to the same composition object. To create a new composition from inside the data input dialog of the connection, we click on the New button in the composition line. We enter water steam for the name of the composition and then click on the OK button. When we enter the data for the composition, we have to remember that we basically create a system of equations that defines the process. The composition contains one equation which defines that the sum of all mass fractions must be 1. To fully define the composition, we must set all but one variable. The remaining variable is then calculated using the model equation. Since we want pure water, we leave water undefined and set all other components to 0. We now close the data input dialogs of the composition and the stream by clicking on OK and run a new calculation. IPSE GO reports that it is underspecified and there is a degree of freedom of 3. The system has 10 equations and 13 variables. This means we have to set 3 more values to make the system fully defined. We did not define any physical properties. Let us set temperature and pressure at the source and run the calculation again. IPSE GO now reports a degree of freedom of 1. It also displays a list of possible settings. In our case, this list contains the mass flow in the source, in the stream and in the sink. You can select one of these variables and set it to a fixed value. In a more complex system, it can be helpful to display the possible settings directly in the flowsheet. You can do this by clicking on the Analysis Results button. IPSE GO displays boxes with the possible settings on top of the components. When we run the calculation after setting the mass flow, IPSE GO can successfully solve the system. IPSE GO displays for all connections a data cross with calculation results. We can now add a reference cross for the stream to make it easier to identify the values in the data crosses. Let's now see what happens if we select an invalid combination of settings. It is obvious that we cannot set the mass flow at the source and the sink. But let's do it anyway and run a calculation. IPSE GO reports that the system is overspecified and displays a list of settings that are in conflict with each other. You can remove one of these settings in order to reduce the degree of overspecification and run the calculation again. If you make changes that you don't want to keep, you can always use undo to return to previous steps. Once you are satisfied with the results, click on the Save button in order to store the project for later use. Click on the Back button to return to the dashboard. In this video you have seen some very basic functionality of IPSE GO and APPlib. Have a look at the IPSE GO and the APPlib manual for more detailed information. You may also want to check for additional video tutorials. Thanks for watching.